guys, this is lesson 3.1 and 3.2. Let's start off our lesson with a warm-up about the standard form that we talked about in our previous lessons. The PTA sold tickets to a football game. Adult tickets are $10 each and student tickets are $5 each. The PTA collected a total of $550. Go ahead and pause your video and see if you can write the equation in standard form and find the x and y intercepts. Okay, so this tells us that we are selling adult tickets and student tickets. Those are the things we are comparing. So the very first thing we want to do is identify our variables. Since adult tickets come first, I'm going to call my x variable adult for adult tickets, and my y is going to be my student tickets. Okay, writing the equation in standard form. We know that we're selling adult tickets and they're $10 each. The word each tells me I need to multiply, but we don't know how many tickets were sold. So I'm going to say $10 per ticket, okay, per adult ticket, so 10x. The word and tells me that I am adding, okay, what my adult tickets plus my student tickets. Student tickets are $5 each. So again, I see that each word, so I'm going to say 5y because y was our student variable. And then we know the total tells me equal, was $550. So this is my equation in standard form, okay? To find the x and y intercepts, that's when we use the cover-up method. So I'm going to go ahead and grab a box here, and we'll go ahead and make it red. Doesn't matter, you can make it whatever color you want. You can use your finger to cover it up. So if I make my x variable 0, okay, that means I'm finding my y-intercept where it crosses the y-axis. Okay, and then I'm going to take 550 and I'm going to divide it by 5. Okay, so I know 55 divided by 5 is 11, but this is 550. So 550 divided by 5 gives me 110. All right, so then for my x-intercept, I'm going to take my box and I'm going to cover up my y variable and I'm going to solve for x. So this time, instead of my x being 0, now my y is going to be 0. We have to figure out what the x is going to be. Okay, so for this one, I'm going to divide both sides by 10 and I get 55. Okay, not only do we have to find these, we need to also understand what they represent. So in this one, this order pair tells me that I can get 0 adult tickets and 110 student tickets. Whereas this one tells me I can buy 55 adult tickets and 0 student tickets. And that's how much I could buy my extremes for $550. Now there are points in between. There's combinations of adult and student tickets that I could buy, but as far as the intercepts, that's what those two things mean. They're kind of the extremes. If you buy no adult tickets, how many student tickets could you have? And if you buy no students, how many adult tickets could you buy? All right, so this lesson is 2 lessons combined in one. The first one is on 3.1, which is relations and functions, which should be a review from previous courses. So we're going to go kind of fast through that portion. And then when we get to 3.2, that is more of our linear functions that we're going to be focusing on for Algebra 1. Okay, our learning objective by the end of this class, you should be able to tell if a relation is a function, and you should be able to identify the domain and the range. Okay, so first off, what is a relation? A relationship or a relation is a set of ordered pairs. Basically, a relation describes the relationship between an x and a y. So this is an example. These ordered pairs here are an example of a relation. Okay, they show the relationship between the x variables and the y variables. Whereas a function is a relationship where each input or x value has exactly one output. So in our function table here, you see every x has exactly one y. Now I know you may be seeing these 13s down here and you see that they repeat. Here's my general rule of thumb. I say no repeating x's. No repeating x's. Okay, so I like to think about this in relationship terms. Okay, ex-boyfriends, ex-girlfriends, you don't want to repeat them. You don't want to repeat history. Whatever was bad with that ex-girlfriend or boyfriend is going to happen again. So do not repeat your exes. So when you're looking at these, do any of my X values repeat? No. Okay, the Y's we don't care about. So let's test this theory out. So what we're going to do is we're going to say yes or no, is it a function or not? So in this first one, I'm looking at it, 1, 2, 3, 4. Those are all different. My X's are not repeating. So yes, this one is a function. Okay. In the second one, looking at my X's, 0, 8, -2, and 6, there's no repeats. So this one is also a yes. All right, I'm going to copy and paste real quick. All right. In my third one, okay, over here, I see I do have repeats. I see my 4 and my 4 repeat. So this one automatically is a no. It is not a function because each X does not go to its own Y. Okay, there's an X value that goes to 2 different Y's. Okay, we can also look at it not just in function tables, but we can also look at it in ordered pairs. So when you're looking at the ordered pairs, you are only looking at your X values. So in this case, we're going to look at all the first numbers, 6, 4, 6, and 2. Are there any repeats? There sure are. We have a 6 here and a 6 here. So this one is not a function. Okay, what about the next one? We have 5, 3, -2, and 0. There are no repeats there. So this is a yes. Okay, we can also look at graphs. You may remember how we test functions in graphs. When we're doing this, you're looking for the vertical line test. So if I were to draw a vertical line, I'm going to make a thick vertical line, straight up and down. And if I take this and I slide it left and right, is there anywhere where there would be 2 points hitting in the same line? So I put it right here. There's only 1 point. There's 1 point. 1 point. I'm going to keep on sliding. 1 point. 1 point. There's no duplicate points on the X's. Okay. So it's not like there's 2 points directly above each other. So this one passes the vertical line test. So we can say, yes, it is a function. Now, if I take the same vertical line and I slide it over to this one over here, okay, if I put it right here, do you guys see how it crosses the line right here and again down there? So it hits twice. So this one does not pass the vertical line test. So no, that one is not a function. Okay, you could only have one X for every Y. Okay. And then we can also look at it, these ones here, these are mappings. And basically you cannot have 2 lines coming from the same X. So in this one, all of our X's have their own lines. So this is a function. But this one over here, see how we have 2 lines coming from our 5 and we have 2 lines coming from our -3. So that is not a function. If you're not sure how to read these, you can always write them as ordered pairs and then look at the ordered pairs. For example, -2, 1 would be an ordered pair, 1, 2, 5, -4, -3, and -2. And then you would see that there are no repeating X values. Okay. All right, so let's talk about domain and range. Domain is the set of all inputs or all of our X values, where range is all of our outputs or our Y values. Okay. So you can think about that in ordered pairs. You can think about it in graphs. Okay, in this one, we have these sets here. Okay, the domain, like we said, is all of our X values. So our domain, we would list them from least to greatest. And you don't want to list any repeats. So we can use this little symbol. We could say 1, 2, 3, 4, and 5. So basically all we did was list all of our possibilities. Now for range, even though there are 5 numbers there, we only have 3 possibilities. We have 11, 12, and 13, because even though 13 repeats, we're not going to list it more than once. Okay, it's all of our possible Ys. We do the same thing with ordered pairs. So domains are all of our X values. So I'm again going to put them in order from least to greatest. My smallest is 0, 2, 3, and 4. All right. Now my Y values, I'm also going to put in order from least to greatest. So it looks like 4, 7, 8, and 9. Okay. All right, so now we have to think about what domains and ranges are reasonable in real life situations, because there are some times when you could have negative numbers or decimals, and sometimes you could not. So the first one says a hose fills a 10,000-gallon swimming pool at a rate of 10 gallons per minute. So thinking about what is coming into the situation and what is coming out. Okay, so the values that are coming in, our X value would be our minutes. Okay, and the Y would be the gallons. So could you have part of a minute? Yes, you could have half a minute, which would be 30 seconds. You can have anything in between. Could you have parts of a gallon? Yes. Okay, so this one could include decimals, and it says that a reasonable domain is from 0 minutes to the time it takes to fill the pool. Okay, because obviously it's not going to be negative time. And then obviously we would stop when we get the pool full. A reasonable range is from 0 to 10,000 gallons. So again, 0 means the pool is empty, and 10,000 is the maximum the pool will hold. So that's why we have limits on this. Okay, a restaurant needs to order chairs for its tables. 1 table can accommodate 4 chairs. So in this case, the chairs are what's coming in, the tables are what is coming out. So this one, a reasonable domain is from 0 tables to the number of tables needed, because we're not sure exactly how many tables would fit in the restaurant. And a reasonable range is multiples of 4 from 0 to 4 times the number of tables needed. Okay, because each table holds 4 chairs, all of our possible ranges have to be a multiple of 4. Okay, you wouldn't want to have 1 table with 2 chairs and another table with 4 chairs. Okay, so just thinking about reasonable domains and ranges are important. This one would not include decimals because you're not going to have part of a chair or part of a table. Okay, and then quickly, this part is not going to be on the formative or summative, but you may see this on MCAP. Discrete domains include whole numbers and integers. They're individual points. Continuous functions have lines and curves. So this way I think about it, discrete, you have to pick up your pencil when you draw these. Continuous is smooth and flowy, and you don't have to pick up your pencil. You can draw lines and curves without doing that. So in the examples below, this one would be an example of continuous because I can draw my line without picking up my pencil. Okay, it includes all whole numbers and integers and everything in between, includes decimals and parts of things. Discrete data, see how I have to lift my pencil every single time I go up? Okay, that one means that the only possibilities are individual points. And that's what we talked about. This one was the pool problem. So you can have parts of gallons and parts of minutes. But over here, we could only have whole number answers. And then you can see the multiples of 4. Okay. All right. And so I'm going to skip this one just for the sake of time, but I do want to have this bonus question real quick. So this bonus question, the first thing you need to find is what is the domain and range, and is it a function or is it a relation? So go ahead and pause your video and see if you guys can figure this one out. Okay, so when it comes to domains of discrete data, okay, this is going to be individual points. So remember, domain is all of our X values. So all of our possible X's. So I always start from my left to right. So one possible point is at -4. Okay. My next possible point, even though I have 2 of them, remember we only write it once, my next possible X would be -2. Okay, my next possible point is right here, which is sitting at -1. And then again, over here, I have 2 points at the same value, but they're both at when x equals 3. So those are all my possible x values. For my y's, I'm going to look at my y-axis this time. And again, start at the bottom at my lowest number. So it looks like I have 2 values that are at -2. I have 1 value that is at 0. I have 2 values that are at 1. And I have 1 value that here at 2. So it depends on if you look at your x or your y axis. Okay, is this a function? So would it pass the vertical line test? No, it is not. It failed the vertical line test 2 different places. So if I draw a line straight down here, it fails there because it hits twice. And it would also fail here because it hits twice. Now, is it a relation? Could I write these ordered pairs? Yes. So sometimes it could be a relation, but it's not a function. Okay, so now we're moving on to 3.2, which is linear functions. With our linear functions, we're going to be talking about function notation, which is the way that we write our linear functions. We're going to be looking at some graphs, and we're still going to continue talking about domain and range. But you're going to see these represented in many different ways in how we say it and how we write it in tables and in graphs. Okay, so first off, function notation, I think of a function machine. So your x is your domain. It's what you put in. It goes through the machine, goes into an equation, and out comes our output or our range. Okay, so our domain went in. This was our domain, our x value. Our range or our y value came out. And notice how they call that f of x. F of x and y are the same thing. So from this point forward in this course, we are going to be using y equals and f of x equals simultaneously. So they both mean the same thing. So if you ever see f of x, just think it's the same thing as y equals. And that's the way we say it, f of x. Okay. So here are some examples of functions written in function notation. So this first one says f of x equals f times x plus 2, or 4x. I don't know why I said fx. 4x plus 2. And this is how we would evaluate functions. It says find f of 8. So since x is the one that's inside the parentheses over here, that tells me the 8 is going to go in the place of x. So this first part is just the name of the function. We're going to say f of 8 because that's what we're trying to find. Okay, so this part never changes. It stays f of 8. But on the right, we're going to substitute our x, 8 for x. So we could say 4 times 8 plus 2. All right, doing order of operations, I have to do my multiplication first. So 8 times 4 is 32 plus 2. So that means my final answer, f of 8 equals 34. So you're basically substituting the value in. The first part is just simply the name. Okay, so I want you to pause your video and see if you can try 2, 3, and 4. All right, let's try number 2. This time, instead of saying f of x, they used a different variable. They said h of x. And that's just to distinguish that these are 2 different functions. Okay, they use lots of different letters. They do try to avoid I because it kind of looks like another number. Well, I is another number we're going to talk about later this year. So in this case, I'm going to substitute -9 in. So I have h of -9 equals 4 times -9 minus 2. Okay, so if I go ahead and solve this, 4 times -9 is -36 minus 2. So be careful when you're at -36 on the number line and you go 2 spaces to the left, you're actually at -38. So in this case, h of -9 is really -38. Okay. All right, this one down here, we have f of x again. This time they're substituting 3 in. So we're trying to find f of 3. So I have 4 times 3 plus 1. So 4 times 3 is 12 plus 1 is 13. So f of 3 equals 13. Okay, so it's just like when you guys learned, I don't even know when you learned it, probably 5th grade, 6th grade, evaluating expressions. You're just substituting numbers in. It's the same thing. They just put this fancy name in the front. Okay, this one we have g of x. So we have g of negative 2 equals 3 times negative 2 minus 5. Well, 3 times negative 2 is negative 6. And if I move 5 spaces to the left, I'm actually at negative 11. So g of negative 2 equals negative 11. All right, so let's take a look at this. Caution. Okay, look at this one. This one's a little bit different. It says find the value of x when h of x equals 0, and they give us this expression. H of x equals 0 is not the same as just saying h of 0. So this one over here is what you saw on the screen before, where you would take your 0, you would put it in here for this x and solve. This says h of x equals 0. So this is telling us that this portion right here is 0. Okay, so I'm going to put 0 in this side, not on the right. So I'm going to say 0 equals 2x plus 3. Okay, because this whole piece equals 0, not just the x. All right, then I would solve for x. So I want to subtract 3 from both sides. And then to get rid of my 2, I need to do the inverse. So I need to divide by 2. So x equals negative 3/2, or you can say negative 1.5. Okay, so just be on the lookout. These two things are two separate things. It all depends on how it's written. Okay, now we need to know how to write functions from a table. Okay, when we're looking at tables like this, we're talking about the number of bracelets and cost that you can make. Our x is usually on top if it's written horizontally like this, and our y is on the bottom. Okay, so they want us to write the slope-intercept form of this rule. So the first thing that we're going to do is we are going to find the slope. Okay, so we have two ways of doing this. You could look at these as ordered pairs, like 117 to 32, and you can use that y2 minus y1 over x2 minus x1. That's fine. You can use that. Okay, or we can think of it as the change. This is how you write it, the change in y over the change in x. Okay, so that triangle just represents the change in. So our change in y, okay, if we're going from 17 to 32, 32 to 47, 47 to 62, what is happening each time? Well, let me go ahead and subtract and see. It should be the same thing across the board, no matter what it is, but each time we're adding 15. Okay, so on top, it would be 15. Okay, and then what's my change in my x? What's happening every single time? Well, we're adding 1. So my change in y is 1. So that means that my total slope, or my rate of change, is 15. Okay, now we need to figure out, if I go into slope-intercept form, that's y equals mx plus b. I know that my slope is 15, but I'm not sure what my b is. So this is where the point slope form comes in handy. So I get to pick any point that I would like. Let's say I choose the first one. I'm going to choose the point 117. Okay, remember I have an x and a y. So I can substitute this and my slope in, and I can figure out what that b would be. So I can say 17 equals 15 times my x, which is 1, plus b. Well, 15 times 1 is 15. And if I subtract 15 from both sides, I get 2 is my b. So I can then add plus 2. And this would be my final equation in slope-intercept form. So first find the slope, then use the slope and that point, any point you want, to find the intercept. Okay, so here are 2 for you to try. Be careful, this one does include a decimal. Okay, 2 decimals. So pause your video and see if you can find the linear equation that goes along with both of these. All right, so the first one, again, we're going to think about what's the change in my x. change in y, because y goes on top, over the change in x. Okay, change in y. So if I'm going from 6.5 to 13, 13 to 19.5, and so on, if you subtract 13 minus 6.5, let's see what we get. We get 6.5. And then if I test here, this is also 6.5. Okay, every time we're increasing by 6.5. Okay, our change in our y's is we are increasing by 1 every time. So the slope, m equals 6.5. All right, now we need to pick a point and we need to figure out what our y-intercept is. Now I would go with the ones that are not decimal. So I'm going to go with 213. You can choose whatever point you would like. Just make sure that you substitute 2 in for your x and 13 for your y, or whatever point you chose. So if I go in, my y is 13, my m is 6.5, my x is 2, and I'm trying to solve for b. So 6.5 times 2, that gives me 13. Whoops, 13 plus b. And if I subtract 13 from both sides, I see b equals 0. So when I'm writing my equation, I have my b, I have my m. This one's going to be y equals 6.5x. There is no y-intercept. Okay, so now let's go over here. This one, my change in my y over my change in my x. So my y's are increasing by what every time? Okay, they are increasing by 3. And what are my x's increasing by? 1. So just be careful. It's not always increasing by 1 on your x's, but for all of our examples we've had here, they are. Okay, so that is my m value. So now I need to pick a point. You can choose whatever one you want. I like 2, 4, so I'm going to use that. So I can say 4 equals, my m is 3, my x is 2, and then I have plus b. Well, 3 times 2 gives me 6. And if I subtract 6 from both sides, I get -2 for my b. So if we put all of those pieces together, we have y equals 3x minus 2. All right, if we were to graph this, whoops, I think we're missing a thing in there. If I go forward too much. I think I'm missing a slide here. But let's go ahead and evaluate this one for when x equals 8. Okay, so that's like saying find f of 8. And here is our expression. So if 8 is in the x spot here, I'm going to substitute 8 in for all my x's. 2 times 8 gives me 16. Minus 3 gives me 13. So f of 8 equals 13. Okay. All right, there is a exit ticket for you to complete on Schoology. If you have any questions, come visit me in our virtual classroom.